Hi everyone. In this video we're going to have a little bit of fun here. We're going to answer a very fundamental question first and foremost. And the question is, why does -1 times -1 equal 1, or positive 1? And I call it the story of me, myself and I. Notice the I's lowercase. And something else that we're going to discover today is we're going to discover the meaning of something that's quite strange. This thing. Last time I checked, if you enter in the square root of -1 in your calculator doesn't quite like it. But does this mean anything? And what's that got to do with -1 times -1 equal 1? Let's have a look. First of all, let's talk about the geometrical representation of a number. In other words, can we use geometry to represent 1 and -1? And of course we can. You would have seen this once upon a time. Okay, so let's say 1 and -1, -1, that's positive, that's negative, okay, and there's our number line, okay, and we can represent numbers as, in fact, we can represent numbers as arrows on a number line. So if we wanted to represent the number +1, we could draw an arrow from 0, pointing in which direction? To the right-hand direction, pointing to +1, okay, and this arrow, the length of the arrow is 1, mind you, and it's pointing in a certain direction. In fact, that's what positive means. Positive, or can mean, pointing to the right. Okay, so we have a sense of direction here. So positive, negative really just talks about direction, or indicates the direction of an arrow. The length of the arrow itself, well, we could measure that. Doesn't matter which way the arrow is pointing. The arrow itself has a certain direction too. Okay, so what about the arrow for -1? Where would that point? Okay, and of course you'd be correct in saying that if I start from 0 and draw the arrow back the other way, the red arrow, it's also, its length is 1, but it's pointing to the position that's indicated here, -1. It's pointing in the negative direction. Okay, so what just happened then? So this blue arrow became a red arrow. Okay, and so this +1, okay, if we multiply that +1 by -1, what happens? The blue arrow, in fact, rotates around 0 or about 0 and becomes -1. Okay, and in fact, I'm just going to put a negative number here just to indicate that it's actually an arrow of length 1, 1 meter, 1 centimeter, and it doesn't really matter. But it's actually pointing to the left-hand side, okay? So there's east, there's west, positive, negative, great. So what we could think about here is that if that toothpick represents an arrow, multiplying a number by -1 doesn't do anything to the arrow apart from spinning the arrow around. So it's like the arrow has turned around and is now facing to the left. Okay, so let's say we take this -1, this arrow -1, and I multiplied it by -1 again. So let's take this arrow and multiply it by -1. What do you think is going to happen to the arrow? The arrow is going to turn anti-clockwise again, and it's going to go back and face to the right again. Okay, so multiplying by -1 means what? We're going to spin the arrow. Okay, 180 degrees anti-clockwise. That's it. So every time you multiply something by -1, the arrow will flip. It will turn the other way. It'll turn back the other way when you multiply by -1 again, and again, and again, and again. So every time you multiply something by -1, it's a rotation of 180 degrees. Okay, same thing here as well. 180 degrees. Okay, so take home point, at least for now, when you multiply something by -1, it means spin the arrow 180 degrees anti-clockwise. Okay, so against the direction of an analog clock. Okay, so there's the geometry link with multiplication by -1. So numbers meet geometry. Okay, so let's move on then to the next part, and this is where let's answer this question now. I think we'll basically answered it, but let's answer it again. So this arrow here, okay, 1 and -1, that's positive and that's negative. So if I take this arrow represents -1, and we multiply it by -1, okay, what's going to happen to the arrow? The arrow is going to turn 180 degrees, okay, so it's a rotation, okay, of 180 degrees, and it's now going to face, right, it's going to point to the right. The arrow itself has not changed in terms of its size, in terms of its length, it's just pointing the other way, okay, and where's it pointing? It's pointing to +1, so -1 times -1 means spinning 180 degrees, and it becomes +1. So the next part then is, well, we're talking about arrows that seem to only point left and right. Can the arrow, as it's pointing, so maybe if I get our toothpick again, right, there's the toothpick there that represents our arrow. Is it possible that as the arrow is turning, to stop the arrow halfway? So rather than having arrows that flip 180 degrees and it's only ever pointing left and right, you and I know that things could, you know, be pointing upward or downward as well. What's to stop us? Okay, we live in a multi-dimensional world. Okay, at least our 3 physical dimensions. Okay, we've got left, right, up, down. We've got depth as well. So how can we represent this arrow stopping halfway? Okay, so instead of spinning the arrow 180 degrees, we're going to spin it 90 degrees. Okay, so this is where the fun begins. Right? So this is the real fun stuff now. Okay, so what I'm going to do is I'm going to draw the number line again. Okay, favourite number line, and 1. So there's -1, and there's +1. Sorry, I'll just draw that a little bit neater there. -1. Okay, and there's positive, and there's the negative direction there. This time around though, instead of having an arrow pointing to the right or to the left, let's start off with the arrow pointing to the right, but instead of the arrow pointing 180 degrees when I multiply it by -1, let's come up with something that defines the arrow, or that means the arrow is pointing upwards. In other words, a 90-degree rotation. I'll do this one in green. So what we're going to do is we're going to, same arrow, okay, same length arrow. We haven't changed the length of it. If you measure the arrow, it should still be the same. Sorry, it's not exactly to scale, but okay, we want to try and come up with something, multiplying this blue arrow by something so that it becomes the green arrow. In other words, it's moved in this direction, but only 90 degrees, not 180 degrees. Okay, so what we're going to do is we're going to invent something here. Okay, rather than multiplying by -1, remember, multiplying by -1 means turning the arrow, okay, spinning the arrow 180 degrees, okay, anti-clockwise, so it points the other way. This time around, I'm going to invent something here. I'm going to invent this multiplication by a very, very special symbol called I. We don't know what that means just yet, don't worry about that. And I'm using it for a reason. Okay, I could use anything. I could multiply by a triangle or by a star or any symbol you like, but we'll use the letter I for a moment. So what we're going to do is we're going to take the number 1, okay, this arrow that represents a +1, so I put positive there. If we multiply it by I, okay, we end up with this green arrow. Now, let's use some very basic algebra. What's 1 times I? Okay, 1 times I is just I. So this green arrow is not a number as a traditional number that we've all grown to sort of know and love from, you know, the day we were aware of numbers, but it's an arrow that points upwards, and we got to give it something different here, different representation. So this is the arrow that is in fact positive I. It'd be nice if we could give this I a number or something. I mean, we're just dealing with a pronumeral here. It's a symbol. It doesn't mean anything at the moment. All I see, if I see this letter I here, if it's a positive, it just means, oh, arrow points up. It's neither positive nor negative. It's a positive I, but it's not like a positive 1 or a negative 1. It's not an actual real number. It's not like, what do we do with it? I'd love to have the arrow pointing again to the left. I mean, how do I get the green arrow pointing to here, to -1? How many more degrees does this green arrow need to turn anti-clockwise to point to -1? In other words, for the green arrow to become the red arrow, so back down this way, okay, we said that multiplying by -I means spin arrow 90 degrees. Okay, spin the arrow 90 degrees anti-clockwise. So we're going to spin it another 90 degrees anti-clockwise, aren't we? Because now I want the green arrow to become the red arrow. What's the red arrow? It's an arrow that points where? To -1. It's just -1, -1. How do I spin an arrow 90 degrees anti-clockwise? What do we multiply by? Okay, if the blue arrow becomes the green arrow by multiplying it by I, and multiplying by I, all it means is spin arrow 90 degrees anti-clockwise. We're going to spin it another 90 degrees. So let's multiply it by I again. What do you have? Let's use a little bit of basic algebra. I, that's the green arrow. Let's now rotate it another 90 degrees anti-clockwise. I times I gives you I squared. Okay, I times I gives you I squared. So this red arrow here is in fact I times I, or I squared. But hang on a moment, where's it pointing? It's pointing to -1. Is there a connection there? So this I squared arrow, so this blue arrow is just the number 1. Right? We multiply it by I, it becomes the green arrow. So it's turned, so it's sort of done this 90 degree rotation. And then this green arrow, which is just the arrow represented by I, we're going to turn it another 90 degrees by multiplying it by I again, and it becomes I squared. But I squared becomes the red arrow, and the red arrow is pointing to -1. So let's make the connection. I squared is exactly the same as -1. So what's I? Take the square root of both sides. I is in fact the square root of -1 if you take the square root of both sides. Okay, to cancel out the square here. So now we know what the square root of -1 means. Technically speaking, it should be plus or minus the square root of -1. But for the time being, let's just deal with the I being the square root of -1 for now, not plus or minus. Okay, just so that we don't complicate things unnecessarily at the moment. Okay, so now we have something numerical that represents this I, in other words. Now, square root of -1 in itself, what is it? It's not really a number as such, as in not a real counting number. How do you count square root of -1 of anything? You can't use it for that purpose. But what it does represents a direction. Okay, so what we've done is we've created another dimension. Okay, traditional number lines are just one-dimensional, horizontal, just horizontal lines. Now we've opened up this possibility of representing numbers not just horizontally, but also vertically as well. Okay, right. How do I then get the red arrow to point downwards? What do you think? Okay, have a think about that for a moment. I want to spin it another 90 degrees, in other words. Okay, so what I might do is I might just rub this off so I give myself a bit of space. Alright. So now what I want is I want the arrow to point downwards. So again, I want another rotation of 90 degrees. So the red arrow, I want it to become the black arrow. What do? 90 degree anti-clockwise rotation. We've got to multiply by what again? By I. Alright, so let's do that. Okay. Oops. Multiply it by I. Okay, so we have -1 times I is -I. So if the green arrow is positive I, the black arrow is -I. But this is also the same as I squared times I. Okay, so that's the same as I squared times I. Okay, so I squared is the same arrow as the arrow for -1. Okay, this is where you've got to make the connection now. Okay, especially in terms of the algebra and also the geometry as well. I squared is an arrow that points to the left hand side, an arrow of length 1. It's the same arrow as the arrow that points to -1. So if we multiply I squared by I, that's just I cubed. So I cubed is the same as -I. Now let's have the black arrow complete the full 360 degree rotation and have it pointing to +1 again. What do? Okay, so what are we going to multiply by? What is the thing we multiply by to get the arrow to spin yet another 90 degrees anti-clockwise, so the black arrow lands back on the blue arrow? And we are going to multiply this by I again. That's what I love. This is so cool. Just by multiplying it by a symbol, it results in the arrow being rotated around. So we can in fact represent anything that spins, okay? Anything that turns, could be the orbit of a the orbit of a planet, or the spin of a planet, or a fan blade, or a motor, or anything. We could represent anything that turns, and in fact we could even stop the arrow anywhere. I mean, we'll get to that later on, maybe in another video, but just for now I think it's just so cool just to be able to say, well, if I want to spin an arrow 180 degrees, we multiply it by -1. Spin it another 180 degrees, multiply again by -1. Every time we multiply by -1, the arrow just spins. That's it, 180 degrees. Okay, we know what that is. Might flip basically all the way around. We could flip and we could turn arrows, instead of 180 degrees, we can turn them 90 degrees anti-clockwise. Why? So we can have an arrow pointing up and down to represent height, for example. Guess where we do something like this? We also do something like this with bearings. So this is not totally unusual, in fact. But this is just using a very special representation to indicate something that is actually turning 90 degrees, and have it pointing vertical up or down. Back to this, -I times I. Okay? So what's -I times I? Okay? Use your algebra skills. That's equal to -I squared. What's I squared though? I squared is equal to -1. So that's the same as saying -1, okay, which is +1. And we've now landed back to where we started, on the blue arrow. So now we've traveled a journey that's gone a full 360 degrees around, all by multiplying it by this very special pronumeral I. And there's a reason why we give it the letter I, or the symbol I. I stands for an imaginary number. So it's a number that kind of doesn't make sense in our reality as we know it. But it can be used to indicate things such as heights, directions, say for example north, south. Okay, so it is in fact useful in our reality. It's just that we just can't use it directly to say count things, for example. Unless you want to count things vertically, for example. Or I mean, when this system was invented, it kind of didn't have much of a use until later on, and then sort of several hundred years later. But I just think, honestly, it is such a cool thing to know, and just to understand that not only do we know why -1 times -1 equals +1, but we've gone one step further to say, well, if we can represent numbers with arrows, okay, the arrows, we can have them point anywhere. In fact, what's to stop me having the arrow pointing here, for example? 60 degrees. Is there a way that we can, is there a way that we can come up with a number, or some sort of a a number that involves this eye, since we seem to have come up with this way of representing vertical numbers versus horizontal numbers. Okay, we call the horizontal numbers real numbers, by the way. Okay, these vertical numbers, or the ones that aim, or sort of where the arrows point sort of up or down, they're called imaginary numbers. Can we come up with a combination of both? Have an arrow where part of the arrow is pointing to the right or east, or to the left, west, and the other part of the arrow, okay, there's a part of that arrow that also points up or down, north or south. Okay, so just something there for you to think about. I really appreciate you watching this video. If you've been able to watch it to this point, and I haven't sent you to sleep, okay, that's really, really good. But this is something that I've really, really wanted to share, and I've done this with junior year groups in the past, and have spoken about this topic in the past, and honestly, it's something that actually isn't as difficult as it looks. We don't see this in any great detail until Extension 2, where we talk about this, but I just think that just using arrows to represent numbers and just employing a little bit of geometry, you can understand so much more about numbers and really appreciate what numbers are and what they could represent, in fact. And so, it's really, really fantastic. So thank you very much for watching, and I look forward to creating another video based on this, where we can extend our understanding of number lines and number planes just that one step further. Thank you very much, everyone.